Hey everyone, it's Miss B, and this is the Unit 1, Lesson 5 Cumulative Practice Problems for Illustrative Math Geometry. We're also going to cover the Lesson 6 practice problems, although not necessarily all of them, so we're including these as one homework assignment. So we're skipping a couple. You can see that we have a couple assignments in here that are labeled as skip. So like number 3 right here, labeled as skip. We're also skipping question 6 and question 8 because we're not learning all of those pieces in my class. So, and so it is important that you keep going on to the next page. This is one assignment altogether with just pieces from both. So let's get started with the Unit 5, or the Lesson 5, cumulative practice problems. Our first question here, we have a diagram, which is a straight edge and compass construction of a line perpendicular to line AB, and it passes through point C. So the first goal is to explain why it is helpful to construct points D and A to be the same distance away from C. So they're referring to the fact that these points right here, D and A, are going to be an equal distance away. So it's helpful for us because if we want something to pass through point C, we can essentially make a perpendicular bisector. And to have them equal distances away from C means that C becomes our midpoint. And when C is the midpoint, that means we'll be able to create our perpendicular bisector passing through that new midpoint. So let's actually put that in some words. If we want the perpendicular line to go through a specific point, it helps to create 2 points on either side that are equal distances away, because then a perpendicular bisector of the segment will pass through C, since it is the midpoint. So I know that's kind of wordy. I did rephrase the question that they gave me, so you maybe don't have to do that. You could probably start with the because, or say it's helpful because, now C is a midpoint of that segment, and we can construct a perpendicular bisector. So I just used a little too many words, but I always like to write a whole sentence that makes sense instead of just an answer or a response to a question. So let's look at question 2. This diagram is a straight edge and compass construction. So now we want to select all true statements and explain how we know. So the first option we have here is that line EF is the bisector of angle BAC. So we have this big angle here. I am going to highlight our angle here. This is BAC. And since this lesson was all about constructing angle bisectors, something tells me we're going to have some angle bisector stuff going on here. So if line EF is the one I am constructing that is blue here, yes, this will be the angle bisector. So we know that, well, we're going to select yes, and then we'll describe why we know that. So A, this is correct, yes. Now we know that because what we actually did was, using that angle, we created points B and D that are an equal distance away, since they're now just radius of a circle. And from there, we created a perpendicular bisector of the invisible line that kind of goes between B and D right here. And that, since B and D are on the rays of the angle, actually then creates something that cuts our angle exactly in half. So let's say that's a mouthful, so how do we word that? We will say EF, yes, because EF is, I'm going to use a symbol for perpendicular, bisector of BD, and AB is equal to AD. So what I wrote basically says, hey, these are the same length, and then we created a segment between them and bisected that. Okay, line EF is the perpendicular bisector of segment BA. That is not true. We just said it was the perpendicular bisector of BD, which is a segment that actually isn't shown here. So, not true for this one. Line EF is the perpendicular bisector of AC. Also not true, because it's the perpendicular bisector of BD. So, not true and not true. Line EF is the perpendicular bisector of segment BD. Yes, this is true. Now this is true because it was constructed appropriately. How can we word this? As we follow the steps for constructing it. Okay, we're going to use the definition of a point on the perpendicular bisector being the same distance away. So you can see that DE is what would be considered a radius, and so is BE of their respective circles, and BD here would be that segment. So just slipped my mind for a second there on how we actually define things being perpendicular bisectors. So we're going to say yes, because. we can say E is equal, well, E and F, sorry, because E and F, both of those are important, are equal distances from both A, nope, not A, B and D. I'm going to say congruent radii, just to be a little bit more specific in case they want to know why we're able to say they're equal distances. Okay, very last option here is that line EF is parallel to line CD. That's not true. We can actually see that CD is a very small segment located right here, actually. And they're just not parallel. So, not one of our choices. Let's move to the next question on the next page. So question 3. This diagram is a straight edge and compass construction. A is the center of one circle, B is the center of the other. That's our situation to start with. Now they're telling us that a rhombus is a quadrilateral with 4 congruent sides. So we want to explain why quadrilateral ABCD is a rhombus. So we want to explain why all 4 of these sides are congruent to each other. So I am going to first start off by stating that circle A and circle B are congruent because they both pass through each other's center. So that actually makes it so that they share a radius, so that AB is considered a radius of both of these. So now that we're saying that A and B are congruent, we can actually identify that we have AC and AD as radii of circle A, and that BC and BD are radii of circle B. And we know all radii of one circle are congruent to each other, and since these 2 circles are also congruent to each other, that means all 4 sides. So let's write that down in some words that make sense. Okay, so let's say B, C, and BD are equal because they are radii of circle B and AC and AD are equal because they are radii of circle A since both circle A and circle B are congruent. All 4 segments are equal. Or congruent. We'll say congruent. That's actually specifically what they asked for, is to explain why all 4 are congruent. And now that we've shown all 4 are congruent, we can say, ta-ta-da, these are all going to be equal to each other with those markings. Okay. Let's take a look at question 4. A, B, and C are the center of 3 circles. Which line segment is congruent to HF? And explain how you know. So I am going to first highlight HF. That is, whoops, this one right here. Now HF, if you can see, is a diameter of circle C, meaning it goes from one side of the circle, passes through the center, and goes all the way to the other side of the circle. So we only have 2 real options here that we know have to be true, and that's either going to be DF or FD or HD or DH, because those are the other segments that are also radii of these congruent circles. And we know the circles are congruent because they pass through each other's centers. So which one of those is on our list? Well, it's not AB, so let's cross that one out. It's also not CD, because CD is the vertical line in this diagram, not that one. DF, yes, DF is the light blue highlighted one. So I'm going to highlight that also here as light blue to show that that's the one that we found. And CB is just a radius of the circle, not a diameter, so not that option. So now our explanation is that HF and DF are diameters of congruent circles. And that's it for question 4. If we move on to question 5, we have a construction where A is the center of one circle and B is the center of the other. So their question for us is to explain why EA, right here, is the same length as BC, which is right here. So why are these two equal? I'm going to say circle A and B are congruent because they pass through each other's centers. Each other's center. And we can say EA equals BC because they are radii of congruent circles. Okay. The other way to explain this would be that the radius of any radii of these circles will have the same length because they share the common radius of AB, but I just like to say the radii of congruent circles because it feels a little more succinct or straight to the point. So that's it for question 5. We're going to keep going. 6, 7, and 8. So fortunately, not all of these questions, even though they look a little bit long, these questions are not entirely long to actually complete. So in this diagram for number 6, AB is perpendicular to CD. So they've told us that using our information here, but we also see we have the perpendicular symbol as well on the right. Now CD is the perpendicular bisector, and they're telling us assume that this line is the set of all the points that are an equal distance away from A and B. So with that in mind, is point M closer to point B or the same distance from both points? Now they're being a little tricky here because they're saying point M and they have point E labeled here, but we have to read because if we answered with E, it would be closer to A, but M is actually on the perpendicular bisect, so we would say it is equal distance from A and B because it is on the perpendicular bisector. So I'm just going to put that little green dot on M just so that we can see, oh, hey, it's actually point M, not point E. Okay, let's look at question 7. All right, I am not a big fan of the way that question 7 is phrased, or of the way that they actually phrase the answer on the answer key. So let's read question 7, and then I'll discuss how they answer this question as a sample response. So question 7 gives us a sheet of paper with points A and B, and it's folded so that A and B match up with each other. They want us to explain why the crease in the sheet of paper is a perpendicular bisector of segment AB. They then tell us, assume the conjecture that the set of points equal distant from A and B is the perpendicular bisector is true. So they're saying, hey, we're allowed to say that the perpendicular bisector is that set of all the points an equal distance away. Now, the explanation they give on the answer key, I'm going to read out loud, but then we're going to phrase this a little bit differently when we write this down. So the solution they give in the illustrative math curriculum is that if C is a point on the crease of the folded paper, a segment can be drawn that simultaneously connects C to A and B while the paper is still folded. It is the same segment, so this means the distance from C to A is the same as the distance from C to B. Since every point on the crease is the equal distance to A and B, the crease is the perpendicular bisector of segment AB. Now, I don't really like the way they verbalized that. So let's say it a little bit differently. And I'm going to use some visuals with my description as well. Just because I would hope that I want to make, your life a little easier. So if we have a fold in our paper, I'm going to say that's approximately our perpendicular bisector. And you draw a line, or segment in this case, using a straight edge, from A to any point on that fold. It would also, say you used a Sharpie and so it's bleeding through your paper a little bit, that would be the same line from B to A. They're just trying to have us use a little bit of some real world context to this. So that's essentially what they're trying to explain, but it seems a bit like a wall of text, or it seems very, very, very academic and difficult to actually interpret in real world context. So I know I also just said a bunch of words, but we'll hopefully write it down in a way that works. When folded, any line segment drawn from A to a point, you know what, instead of a point, let's say any point. On the crease fold. So when it's folded, any line segment that we draw from A to any point on that crease or fold would also connect B to the same point on that crease. That is why it is the perpendicular bisector. So I appreciate you with my long-winded explanation. I appreciate you sitting through that for question 7. It's a little bit tricky. So let's look at question 8, and then we still have a couple questions from lesson 6. So I know this homework assignment is probably the longest one we've had yet. So here's a diagram of a straight edge and compass construction. C is the center of one circle, and B is the center of the other. Explain why the length of segment CB is the same as CD. So, if we look at our two segments here, we actually don't have to do that much explaining to make it make sense. CB is a radius, and CD is also a radius. We don't actually need circle C here, or I'm sorry, circle B here at all, because CB and CD are both radii of circle C, and that is our explanation. So CB and CD are both radii of circle C. That's it. Okay. Now, because this also includes lesson 6, we're going to switch to the next page and answer some questions from Unit 1, Lesson 6, Practice Problems. So, question 1 here, we have, it says, which of the following constructions would help to construct a line passing through point C that is perpendicular to AB? Now we have some options. Construction of an equilateral triangle with one side being AB. Construction of a hexagon with one side being BC. Construction of a perpendicular bisector through C. or construction of a square with one side A, B. Our answer here is going to be option C. We want to construct a perpendicular bisector that passes through C. An equilateral triangle, if we had side AB, would help us make a perpendicular line, but not one that passes through point C. So the point we really want to emphasize here is that it's going to be passing through point C, and so we have to include C in what we're doing. Constructing a hexagon, that's going to be way too difficult. AB isn't necessarily going to make our perpendicular one pass through, and a square with side of AB definitely would not have C involved at all. So we're going to say, for our explanation, I'm going to write out this would make sure the line passes through C and is also perpendicular. Let's specify perpendicular to AB, because that's what we would construct our perpendicular bisector through. Okay, question 2. Two distinct lines, L and M, so they're two separate lines, are each perpendicular to the same line N. Select all the true statements. So I have a really hard time doing geometry when I can't see these things. So I'm going to draw two lines that are perpendicular to the same line, N. So the first line I'm going to draw is N. Since they're both going to be perpendicular to this, I'm going to label this N, just sort of like in a cursive fashion here. And then L and M, I'm going to make red. So they're a little bit of a different color, and I'm going to make them as best as I can perpendicular to this, but it sometimes doesn't always snap to give me things that are perpendicular. Also, if you hear a little bit of meowing in the background, that is one of my cats, so I guess she says hi. So I'm going to call this first line L, and this line M. Now we are going to say that L is perpendicular to N, and M is perpendicular to N. So now that we can visualize this a little bit better, let's select some of our answers. This says that L and M are perpendicular. They are definitely not perpendicular to each other, so this is not true. Lines L and N are perpendicular. Yeah, they actually gave that to us, and that was part of my drawing. Same with option C. Option C says that M and N are perpendicular, so yes. Option D says that lines L and M are parallel, and this is true as well. L and M are parallel. I don't know why that switched to my eraser. L and M are parallel to each other. Now, options E and F both discuss things being parallel, and that says that L and N are parallel. Cannot be true. If they intersect, they can't be parallel. And same with M and N, they intersect right here, so they can't be parallel either. So the correct options here are B, C, and D. And I don't have to write an explanation for this one, but I wanted to provide my drawing as a little bit more of an explanation here, just for your benefit. Okay, we're skipping question 3, and we're moving to question 4. So this diagram is a straight edge and compass construction of a line that's perpendicular to AB passing through point C. They want us to identify which segment has the same length as EA. So what I'm going to do is first of all, EA doesn't appear on this diagram. The points do, so I'm going to connect those points first. And thank you, iPad tools, for making that a nice straight line, since my handwriting is wobbly. And I'm going to highlight this because I want to say same length as segment EA. Segment EA is going to be my green highlighted line. All right. So which one is going to have the same length? Well, that would be any radius of any, well, not of any circle, any radius of A or any radius of circle D. Because circles A and circles D pass through each other's centers. So let's look at what we have as our options. The first option they give us is EC. EC is here. Not a radius of either of those circles, not going to be congruent. ED actually is going to be a radius of circle D, so this one is the correct choice. But let's also just verify that the other pieces are not. So let's look at BE. BE, definitely not the same length. B is all the way over here, not going to be congruent to EA. And BD is a smaller segment and doesn't actually even extend all the way to the side here. If it did, that would be a congruent segment as well. So neither of these two options are our choices. Okay. So we do have more to this assignment. It's not just those those four, pardon me. We are also going to look at questions 5 and 7. So here is question 5. This diagram is a straight edge and compass construction. Which triangle is equilateral, and then explain how you know. So, explanations in geometry are not allowed to be, I can just tell, or they look equilateral. So, even though we might be able to tell that the blue triangle is equilateral just by looking at it, we're going to use geometric properties. So, let's say the blue triangle, or let's actually give it its name. It is touching these 3 points, V, W, and Z. So let's say triangle. Oh, that's a little bit thick for my handwriting here. I want to be able to fit everything. Triangle. And as long as you say the 3 letters in order, it doesn't matter if you go clockwise, counterclockwise, or where you start, but we're just going to give it its 3 letters name. I'm going to call it triangle VWZ, because that is actually alphabetical order. So triangle VWZ is equilateral. Now, let's actually look at our diagram to discover why this is considered equilateral. So, these are all either, well, they're composed of diameters. I was going to call them radii, but they're not radii. So, this side here is a diameter of one of these circles that extends from Z to V. You can see it has an intersection point there, which also has ZW being a diameter of our central circle, and WV as a diameter of one of our outer circles. The one thing that does kind of bother me is that these circles that I'm trying to reference with diameters don't have letters in the middle, so I can't call them circle X or circle Y, because they're not actually labeled like that. So what I'm going to say is that triangle VWZ is equilateral because all three sides are diameters of congruent circles. Now, if I wanted to be extra specific here, I could say that the circles are congruent because they pass through each other's centers. But I think that's a little too much to say here, and we can kind of tell by now that two circles who pass through each other's centers are congruent. Plus, they didn't ask how we know the circles are congruent. They just asked how we knew this is equilateral. Okay, skipping question 6, going to question 7. This is the last question of the assignment, so thank you for sticking with me this long. This diagram is a straight edge and compass construction. A is the center of one circle, and B is the center of the other. Question A, or part A of this question, says, name a pair of perpendicular line segments. Well, this looks to me like the construction of a perpendicular bisector. So I am going to say that AB is perpendicular to CD. And now this says name a pair of line segments with the same length. Because AB is being bisected, that means that AM and BM should have the same length. So I'm going to say AM is equal to BM. And that's it. They didn't ask us to explain why, so that is the full explanation. So yeah, thank you for sticking with me this long. I know it was a very long assignment, but I appreciate you working through the whole thing with me. So that is it for our explanation video of Homeworks 1-5 and 1-6, which is the Unit 1, Lesson 5, and Lesson 6 cumulative practice problems.